you are able to see, you know, the due date is 22nd of February, or here you are saying March 1st because your mobile or computer clock is ahead of Pacific time. Some of you are in Europe or Africa traveling for different purpose. Therefore, don't get confused. Please keep always Pacific time deadlines right here. So keep your, you know, calendar intact with Pacific time and this date, because we are located in Washington State and Spokane, Chini.
Join the meeting.
So look into now. Now I'm going to explain two sample hypothesis testing. Okay. Now we are going to start with what is two sample hypothesis testing? Let's start with very simple concept, and I'm just going to start whiteboard. Hypothesis is nothing but simple assumption or a statement that you would like to prove using data, using statistics. Let's say me and you are sitting together and we are arguing. I am saying Spokane housing prices are higher. Spokane housing prices are higher. And you are saying Liberty Lake housing prices. You are saying Liberty Lake and Spokane, we are comparing with these two housing prices. I'm saying Spokane housing prices are higher. You are saying, no, I think, you know, Spokane and Liberty both are same. And we don't have any conclusive evidence to say I am correct or you are correct. Therefore, we need to do statistics to check whether I am correct or you are correct or both are not correct. So basically I go and I collect a different housing prices. So I go on Zillow. Let's say I'm just going on Zillow. Just a minute, I'm going to share my screen, entire screen. So I'm Zillow, and so let's say recently sold, and I can say tons of remove boundaries. So I can see a lot of houses, and I can say this is a house price 298,000. I can take these, you know, numbers, like I can take randomly 50 numbers from my locality, 50 houses prices from my locality. And now I go on Liberty Lake, and I can do also the same thing. You know, I can go and get the housing prices recently sold, and I can put in my mini tab. So here, for example, I am just going to put Spokane, and you are going to collect Liberty Lake. And my Spokane prices, you know, I will not go and, you know, for demonstration purpose, I'm just going to fill out this about 30-40 housing prices based on integer, and you are going to. So I'm just going to use calc data, and I'm going to use this just a minute, integer calc data. Okay, here calc. Raw statistics column, make data. I have to find, because I just okay, sort, rank, delete, indecent, record, change, calculate the value, column, row, make pattern, make random data, and I go for integer. Where is integer? Okay. And I'm just going to insert the 35 rows. Let's say 45 housing data I'm just going to store in spoken. Minimum value is in the area is about 290,000. And maximum value was like 800,000 in my area. So I'm just going to 800,000. Okay, I put proper. And these are, for example, just, the housing prices are stored here. But you have to just look into the real values which are on Zillow or real. Similarly, I'm going to do for Liberty Lake. Now I'm going to do same for Liberty Lake. But Liberty Lake, no house is in 290,000. Basically, everything starts with 450,000 about, and maximum goes for millions of dollars. So I'm just going to write, and again, I'm going to insert. So now I have the housing prices of two area, which I'm going to. Now your statement is both area have equal housing prices. Okay, so we are going to check here statistics, basic statistics, one sample here, two sample t-test, and we are going to use each sample in its own column. So sample one is spoken, sample two is Liberty Lake. We have different option here. I'm not, equal variance, we will check this 95 by default, sample mean one, and here you can see this is, that means you are saying both are equal, and alternative hypothesis is both are unequal. Okay, so I'm just going to do this, and now I got my result here. Spoken is this, Liberty Lake is this equation, this is a difference, this is a confidence. Now you can see the t value and p value. So the null hypothesis, mu1 means mean of spoken houses minus mean of Liberty Lake houses equal to 0, means null hypothesis both are almost equal. Therefore, so this and this, they are equal, and the difference would be 0, null. Alternative says, no, that is not 0. Not 0 means there is a difference. So what we got here? We got here, first thing, the p value is less than alpha value. Alpha, what we have selected? We selected 5% by default. So p value is less than 1%, or you can say 0.1%, and alpha is 5%. So this is 5%, and p is less than 1. So this is, so we reject the null hypothesis and we accept the alternative hypothesis that there's a difference. So basically you said there's no difference in Liberty Lake and in spoken housing prices. Now we conclude here based on that there's a difference, significant difference, and they are not equal. Now now I said that spoken housing prices are more than Liberty Lake. Let me check my statement now. So I go under statistics, basic statistics to sample t, and let me clear this. So the data is, we have to check this option only. Now this concept, this is equal or unequal. Now look into another concept. Difference is less than hypothesized difference. That means please try to understand this concept here. And difference is greater than hypothesized difference. So basically, I am going to check this alternative hypothesis. I'm saying spoken housing prices are more than Liberty Lake. So basically, if you see, mu1 is spoken minus Liberty Lake. If this is greater than hypothesized difference, which is 0, that means what would be the bigger factor? Spoken is higher and this is lower, then only we get bigger than 0 or more than 0. In case if we select another option, spoken is less and Liberty Lake is more, then it would be more than 0. It is less than 0 because Liberty Lake will be negative. I mean, this value will be less than 0. So our concept, we are trying to check difference is greater than hypothesized difference. Okay. Because it takes alternative hypothesis. Now look into this. So I'm just going p-value is 1. So you can see where is our alternative hypothesis. So basically this hypothesis. So basically this is p-value is greater than alpha value. So we reject B, or in simple term, we accept null hypothesis. Null hypothesis. Why? Because P is greater than alpha value. P is like 100% and alpha is 5%. So this is, the null hypothesis is, null hypothesis is like this. Spoken prices of Spoken and Liberty Lake is less than equal to 0. Alternative, Spoken minus Liberty Lake is greater than 0. So basically our this hypothesis is correct. 0 or less than 0, because Spoken housing prices are lower as compared to Liberty Lake, which is correct. And let's check another thing, which is the third hypothesis, that Liberty Lake housing prices are more than Spoken Spoken prices. So I'm just going to do the same third option. Let me clean this. Now I'm going to do this, which is difference is less than. Okay. And here you can see p-value is less than, which is correct. So null hypothesis is this, in this case, H0 Spoken minus Liberty Lake is greater than or equal to 0, and H1 Spoken minus Liberty Lake less than 0. So this is null hypothesis. Therefore, we reject this. We reject the null hypothesis because p-value, and we accept the alternative hypothesis because p-value is less than alpha value. And you can see this. So this is two sample hypothesis testing. You can compare the two salaries, I mean, any numbers based on this situation. So this is simple hypothesis testing, and I'm going to now go over some of the other options, you go under this situation. Let's say, so this is one case where you have two independent samples. So these are the two independent sample, spoken is different, Liberty Lake is different. They are not dependent on each other. So there are a dependent sample, or you can say, for example, you are going to see before spoken housing prices before COVID, spoken housing prices after COVID. These are paired sample. This is called paired sample. You can see your weight before fasting, your weight after, after fasting. You can say your weight, or you can say different, your salary before MBA, your salary after MBA. So basically you are the only one, only the situation changed before MBA and after MBA. So this is called paired sample test. And in this case, here you go paired sample. That means you have to each data in its own column. Let's say I see, I just change this data, and I can see this spoken housing prices before COVID. And let's say I just, the price increased, spoken housing prices after COVID. So if the situation is changed, I cannot use the two sample. I have to go paired sample, because this is the same situation. Oh, sorry, again, because I'm not measuring the same houses, I have to go and I have to create the same houses for same housing prices. Let's say house number 1616 Best Clark Avenue. Oh, sorry, spoken. So for example, if this is a house, oh, I have to go and do this. House number or house address. So if I say 1616 West Clark Avenue. So if this house before COVID, after COVID, I can say 2020 Best 9th Avenue. So this is the price of this house before COVID, after COVID. Then I can see the same item is measured in two different situations. Then only I can say this is a paired sample t-test, or paired sample has to be. So I have to see all the houses before and after. And so I go and I do the test now, basic statistics, paired t-test. I go under, this. And now options are exactly same. But here p-value is again. So I can say there's no difference, there's a difference between before and after. So there's a difference before and after, because p-value is less than alpha value. So this is what is expected in two sample hypothesis testing. We already covered one sample hypothesis testing. Those who have not done BADM 503, I will request you to kindly review chapter 1 to 9 to get more idea about p-values, about t-values and other things. So this is two sample. Now let me share my some slides. So here you can see there are two types of samples, independent samples, two different groups, and they don't affect each other. Paired sample, two measurements are drawn from the same pair of individuals or object in two different situations or time. So this is, you have to check. Two sample hypothesis testing, like we did in the past, it is based on two sample test, paired sample t-test, based on proportion two sample proportion test, and based on variance like we did in the past. So basically two sample can be based on mean, can be based on proportion, can be based on variance. Under Minitab, you go under statistics, basic statistics, and you choose the correct option. So basically, sometimes you get confused which option has to be selected. And certainly we have only 29 students as of now in the class, and actually there are 240 students. So, many people will not understand and they will be keep using only directly two sample t-test, but you have to see first the data, which one is going to be used. Here you can, I hope you can see my screen. These are the options which are right here. If you can see, two sample t, paired sample, two proportion, and two variance. The hypothesis testing steps from 1 to 6. Identify the test, which test is going to be used. Like above 4 tests are there in this chapter. Basically, we will be using these 4 options to do. So first you check for assumption, equal variance. This is another important concept that we have to look into that, because when we are doing this analysis, here you can see statistics, and here you are going to graph, you are going to check, let's say, basic statistics. I'm just using two sample, and let's say what I am doing wrong. Spoken two sample for me. Oh, I have to check the new variables. Okay, now here this option is available. Can we check this, assume equal variance or not to assume? So this is equal or not equal for this purpose. And there's a slight difference between assume equal and unequal. So let me do once unequal, and now I'm going to do equal. So, and let's see, one is little bit, so this is t-value is 3.6 for this, and here, in this case, it is coming both t-value, both 3.6, 3.6, unequal and equal. But other cases, it could be little slighter, higher and lower. So I think equal variance is little bit higher and unequal is little bit lower. How to decide whether it's equal variance or not, we are going to check. And actually, just a minute. So then you decide your null hypothesis and alternative hypothesis, like we just alternative, write both hypotheses, check the alpha level, 5%, 1%, 2%, 10, whatever. So Minitab accept 1 minus alpha, which is confidence level. So, alpha is 5%. So Minitab accept 95%. Alpha is 1%. Then Minitab accept 99 confidence. So check that. Calculate the test statistics and p-value. So automatically Minitab gives data is provided with questions. You can see reject null hypothesis if p-value is less than alpha, and accept null hypothesis is if p-value is greater than alpha, and write your managerial implication of hypothesis, take action based on decision. So these are the 6 steps in order to make your decision related to hypothesis. 2 sample. There's a question, what about if we have more than 2 samples? If you are going to compare spoken, you are going to compare Liberty Lake, and then you are going to compare Cordlin, 3 areas or Sandpoint. How I can compare more than 2 samples? So, up to 2 sample, you can use t-test, but more than 2 sample, you are going to check, then use ANOVA, which is next chapter. We don't have that. If you can simply do that. You can compare multiple samples using ANOVA. Analysis of variance. Basically, you can see the variance of the different samples in this. So this is the question I think I asked you in assignment. And look into weight of randomly selected. These are international bags weight. These are domestic weights. And we have two samples. One is 37, one is 17, one is I think 20. I don't know exactly. So look into the question here. Examine the data below, showing the weights in pounds of randomly selected check bags for an airline flight on the same day. 5% level. Mean weight of international bag and domestic bag is same. So basically it is asking mean weight of both flights are same or not. So I can clearly see this is a case of two sample hypothesis testing for mean not given. So we can use very simple. These are independent. Do not assume equal variance. Eyeball test, box plot, comparing a standard deviation of both sample, if sample. So I'm going to show you how to do. Actually, this was, I mean, I learned, or my teacher taught me when I was in my undergraduate. And he taught me that, you know, if you don't have the calculator, how you can check whether which it is equal variance or unequal variance. So I learned, still I retain that knowledge. A standard deviation of one sample divided by standard deviation of second sample. If that is less than 2, we can assume equal variance. If this is more than that, then we can assume unequal variance. This is way back, you know, we didn't have calculator computers. So this we used to do eyeball or, you know, first reference test to do that. So I'm just sharing, it is not given in test book, but, and then second is Levine's test is also an option. So null hypothesis, this alternative hypothesis is this for this question, 5%. So Minitab selects 95% or 9, you know, null hypothesis is this, alternative hypothesis is this, p-value is this. So we can clearly see p-value is less than 5%. Means null hypothesis is rejected and alternative is accepted. That means these are not equal. We conclude that there is a difference between mean weight of international bags and domestic weight bags. So this is our process. And now assuming equal or unequal variance. This is eyeball option to plot the, you know, box plot. So this is, for example, you can clearly see this is an international one and this is domestic. You can see clear they are not overlapping. They are not, you know, you can't see they are similar. So you can say this is unequal option, unequal variance. And the second, like I used to do, SD1 upon SD2 is less than or equal to 2, then it is equal, otherwise it is both variance are looking different. Another option, this. Okay, so 11.9 divided by 4.258, which is greater than 2. So this is another option to check whether your equal or unequal variance of the. The third option is this, is to go ANOVA, test equal or unequal variance, consider normal distribution if normally assumptions are made. So, you know, you have to check 503. Now look, app test in case of normality is assumed, Levine test for without normality assumption. And here is a p-value is, you know, again, same concept of p-value. So I'm just going to demonstrate. Let's say these are the two sample. I'm going to check. Here we have statistics, basic statistics, two variance. Here we have two variance. or you can go under statistics, ANOVA. Here you can say test for equal variance. Test for equal variance. Now I select. So here I have the options. Use test based on normal. Are we going to use, because we have these things. If you use the normality situation, okay, go ahead and do this. If you assume these samples are going to be normal, then you will get the, so here, oh, sorry. Here you can see F is 2 point P is less than 0.001. 0.001, you can see clearly spoken higher prices, and you can see these. What do you conclude based on that? Can you show the B formula? Okay, I'm going to show Anna. So look into this. They are not, their variation, different, because they are. So you can see null hypothesis is if P value is greater than, so you say equal, and if P value is less than, this is unequal. So you can clearly see this is the case of unequal variance. Now you ask me about second concept. So I go here. The second formula was standard deviation 1 divided by standard deviation of 2. Now you see the first sample is standard deviation. How much? This is 151,607. And here is 91086. In this case, this is again, this is conflict, because it is coming less than 2. So 91,000. So this is coming less than 2. And it should be, considered as an equal variance based on this. It was old technique, so you don't go with this technique, because now we have sophisticated tools, we have softwares, and that give you clear calculation, clear view, clear picture. You can see clearly in this picture. This is the line. This starts from here, and this is the line. It is here. So these two samples are unequal variance. Exactly, yeah, exactly, Jesse. It's unequal. You can clearly see. Now we assumed normal distribution. We assume normal distribution. Let's look into the. We see the housing prices are normally distributed in Spokane and Liberty Lake, or before COVID, after. Now think about if it is not distributed. So I just go here. I go under this, and we have, where's ANOVA, test for equal variance. Now look into this. Here I don't use that, normally distributed. And now I can see then we have this test, which is Levine's test. And that is also again, similar, like, this is another statistics, Levine, and test statistics and p-value, and which is also showing this is not equal or unequal variance, because based on Levine test, when we don't assume normality, this is the situation. So one of the question is asking international bags and domestic bag, which Denise asked, which we are considering that weight of the, which is asking F test, which is based on the weight of the international bags and domestic bags are normally distributed. Consider that, check the F test for that. So this is equal and unequal option. And now I go here. So we cannot, so if p-value is less than alpha, we cannot assume equal variance or unequal variance. So basically, selecting that option, you have to check this equal and unequal option. And I already explained about this part. Assume equal and unequal variance, we have to do, this option when you select, and these are the three options of hypothesis, what we are going to check. And based on that, you can select the right option. This is alternative hypothesis, not null hypothesis. Minitab is based on alternative. Here, it is clearly given alternative option. Okay. And so basically, this is another question, p-value, and you can, go through. So this is the proportion case. Now, instead of mean, if the question is asking proportion, exactly the same thing. Critically review the data, proportion data, identify the test to sample proportion, check the assumption if any. Null hypothesis, mean proportion 1 minus proportion 2 is 0. Proportion 1 minus proportion 2 is less than equal to 0. Greater than, oh, sorry, I made a mistake. One should be greater than and equal to 0. So basically, one should be less, one should be greater. These should be null hypothesis. Alternative hypothesis should be not equal to 0, greater than 0, and less than 0. Alpha level, again, 95, 99, whatever, confidence level, alpha level and confidence, you can decide based on question. If not given in the question, automatically it takes 95 and do all the calculation if not given based on 95% confidence. Calculate the test statistics, p-value, and make your decision. So basically, all the steps are same. Here, I have just shared some screen test here, right here. And here, this is again question based on equal variance, based on, so basically, one of the question is directly answered on this slide, if you can observe here. And further, I'm not going to do anything. So there's another option to explore the option, Here in Minitab, we have assistant tool. Assistant tool. Under assistant, we have different options. I don't know whether you have explored or not. Here you have hypothesis testing, regression, before, after. So I'm just going hypothesis testing. Hypothesis testing, it has all the options. So basically, in the last course, we learned one sample with the target. This is what we learned in the last. Compare two samples with each other. And compare more than two samples. So we are just, I said, you can compare ANOVA. Based on ANOVA, if you have more than two samples, we are not going, sorry. So we are just going to stuck here, two sample t-test, paired sample, two sample standard deviation or variance. So percent of defect, which is, you can say paired, proportion. So I'm just going to, so I'm going to say two sample t-test. Here clearly each sample in column. So I go here, I go here. So it clearly gives you the hypothesis testing based on the variable name. It gives you combination of all three hypotheses. Is the mean of spoken housing prices before COVID greater than the mean of spoken housing prices after COVID? Is the mean of spoken is the mean of spoken housing prices COVID different? differed from mean. So basically less than, so I'm just going to check this alpha. You can select here. It gives you 3 option of alpha, 1%, 5%, and 10%. You don't have different option. Like if somebody asks about 2%, 3%, 7%, you only have 3 options. Okay. Now here we have all the results. So this is where I can see the p-value, sample size, mean, difference. Okay, here. So p-value is less than 1%. Here you can see p-value is less than which 1%. That means, you know, housing prices of spoken is greater, is less. So basically this is another way of checking and doing. However, you know, I would suggest you to use those options where you can clearly get the statistics and you can clearly get p-value. So here test, you can conclude that mean of the spoken housing prices is less than spoken houses prices after, before and after. So basically clearly gives the comment here, means you don't need, you can get the wording right here. You can conclude that mean of spoken housing prices before is less than the spoken housing prices after at 5% level of significance. And so this is concluded. So basically you can avoid, you know, you don't need to even look the p-value and all. The conclusion is right here. So this is another option. You can go in and see all other option under assistance. So this is about my you know, explanation about hypothesis testing. And if you have any question related to this, please let me know. I think I covered almost everything. Let me check one more time because I think I covered everything. So let me go and download. We download this. Okay, right here. I think I covered. I'm not going into all formulas and all. Here you can always remember degree of freedom. So here you have 2 samples. Let's say in international bag and domestic bag, one is 17 sample, one is 20. Total is 37. Now you have to subtract 2 degree of freedom because you have 2 row. So basically 2 samples. So 37 minus 2. So degree of freedom is 35. So here always keep in mind that all these, I think I covered almost everything in the, yeah. So yeah, I covered everything. So if you have any question, please let me know. This is recorded and it will be shared soon after the class.
I got a question for you.
Yeah, please.
For the